Hello, I'm James Helfrich. One of the most common ways to teach students data structures is to have them implement the data structures from scratch. This video will demonstrate a collection of resources designed to help students with this process and help teachers with the grading process as well. Every data structure has three versions corresponding to three different levels of difficulty. The 85, 100, and 115. I let my students choose between which one they want to do, so they get more points for a more ambitious version. Let's take a look at the 85 version of the vector. In the 85 version of the vector, then we have a vector of always integers. And of course, it's going to grow and shrink according to pushback and resize and things like that. In the 100 version, it's the same thing, except it's a template of type T, so the client gets to specify which data type they want to use. In the 115 version, it's also a template, it also grows, but it also has an allocator. And the unit test associated with this particular assignment counts how many copies and assignments and moves that the data structure makes to make sure it is on task. And all this is done with a SPI. A SPI is a double that counts the number of times it's been used. It counts the number of times the default constructor has been called, or the copy constructor, or the move constructor, or the destructor, and so on. And then you can query these. And then we also have unit tests, which reset the SPI and then make sure the appropriate number of copies, moves, and so on are called. For an example, in this particular unit test, I'm going to copy a partially filled vector. So I'm going to start with two elements and two that are empty. And then when I call the copy constructor, then I expect to have two copies and two Alex, but nothing else called. Otherwise, then we will report the errors to the client. Let me show you another example. In the binary search tree, the 115 version does red-black balancing. And so when I look at test BST, then we have a whole bunch of different unit tests for constructors, for assignment operators, for iterators, for find, for insert, and then insert tests each individual case of the binary search tree balancing one at a time. And so when we take a look at some of these tests, so here we're going to case 4, C, and this is a simple one, so we're not going to have any children under it. The before has a black node and a red node. And then when I insert S, which is the value 40, then I expect to have two compares, one copy create, and one allocate. Let's take a look at a more complicated example for A. So I start with black, a black, a black, and a red. And then I'm going to insert 10, which will be right here. And this will execute for case 4A. And then here I expect to have three compares, one copy create, and one allocate. And the final tree will look like this. One great thing about using the unit test approach to verifying the student's work is that you could just run their code against the unit tests and get a percentage of tests that pass, which makes it really easy to grade. But it's also really great for the students because they get a copy of the unit test. So they get to exercise their version against yours, against your key. And it's almost like gamifies it. So they can do one small step at a time. They can try to get one test to pass, which would be like 5 minutes of work, then another one, and they can incrementally see their progress as they work to the solution. In other words, it's definitely not all or nothing. And so for this 115 version of the unit test, they get 115 stub, and the stub looks like this. So every single function is stubbed out, which means that it will compile, but all the unit tests will fail. And then if, for an example, if the students implement clear, then they can just get 1 or 2 or 3 unit tests to pass without having to worry about the rest of the program. And this is going to allow for an incremental approach to solving the problem, which frankly is basically test-driven development. Every data structure in the C++ data structures textbooks has these 3 different unit tests: simple, intermediate, and difficult. Each one of them has both the key and, of course, the stub the students start with. My students have found this to be not intimidating. They can approach the data structure implementation in small bite-sized chunks, and it's rewarding as they slowly make progress towards the final solution. It is also really easy for me to grade. I can give them an objective grade, which is very predictable for them to understand in just a few seconds. And then I can focus all my effort on commenting on the quality of their code. I hope you'll find these materials to be as useful for teaching as I do.